that we had for a quiz. So we used a special formula to get so-called z-score 34. Thank you for confirming. That is value of x minus so-called population mean divided by a population standard deviation. So last time we noticed that there was a special pair of symbols utilized to describe the population mean. So for this example, it will be 100. And the population standard deviation that was in this example equal to number 16. So at this stage, we need to figure out the so-called z-score that will be found by this little formula when x was equal to 76. So all you need is to carefully put these three numbers in instead of x number 76, instead of population mean 100, and then divide this by standard deviation, which is a 16. Oh, I'm sorry. I think I'm not using the right values. I need to wake up. I think that's what is going on. So we don't use this tool because we're actually not in that group of exercises. We're up here, right? So mu is 60 actually, right? And the standard deviation is actually 8. So I better put 60 instead of mu. Well, whatever numbers are technically, we don't really pay much attention, but of course we want to make sure we put the right numbers, not some different numbers that do not belong here, right? So let me fix it real quick. So I subtract 60 and I divide by 8. And you can put this in your calculator, just make sure you put parentheses around your numerator if you don't want to do this by hand. I think it's 2, but during the test, you can always be on the careful side, right? You can just make sure you put it in a calculator if you want to, of course. And then divide this by 8 and get the answer, which is indeed equal to 2. So I think that pretty much all people in class got this correctly. If you didn't, you know what to do, or you already forgot. You can always do even exercise, right? From, I think, this page, from this group of exercises, it would be very hard to do one even exercise to make up for this quiz or for some other quiz. So I think that's a great little section that we'll be working with more, because it definitely needs to clarify what is that we're actually doing in here. And it turns out that we're preparing ourselves to find so-called probabilities. So we're back to the probability story. And it turns out that in these sections, they try to tell you that area under this bell-shaped curve is always equal to 1 because it's called distribution. Distribution means we have entire area under the distribution curve. So what's distribution? Well, this function, the one that gives you this picture. So this is your x-axis and function that gives you this bell-shaped nice picture. Well, that area is equal to always 1, turns out. So using this fact that it is 1, so it'd be distribution, I can verify that we have this area cut into 2 regions, like the region here on the left from the center, and same region on the right side, because picture is symmetric, so they have to be the same. And notice that area here will be half of 1, which is 0.5. Half of the area. Well, again, I utilize the fact that we are dealing with distribution here. And since we're dealing with the distribution, then the whole thing is 1 or 100%. 1 or 100%, that's the thing. Well, so if we consider this z-score story, then we're dealing with so-called standard normal distribution. Standard normal, not just normal, but standard normal. The reason is it has the number 0 here in the center. Because in general, distributions don't have to have 0 in the center. Like in the previous example, we had distribution with mean equal to 60, so there was 60 here. But for the standard normal, the 0 will be in so-called mean, the average, 0. I know it's pretty rare when your average is 0. Usually it's just about any number. And that's why they decided to call this as a z-axis rather than x-axis, because x is any value on the horizontal line. We call it as x-axis. But in order to tell apart the standard normal that has a 0 for mean, well, we call this as a z-axis. And that's the reason why we have this z-score formula in here. So what I would like to do is take a look at some of the z-scores in here. And let me share with you one very interesting piece of information, so-called tables for the distribution. They called the Triola tables. That's the name of the author who was really into this table, so called Mr. Mario Triola. And I can click on this first choice, and he has those statistics tables that I want to show you how to use in this little file, which is available for free online. So here, so-called z-scores, right? So this table contains a few pages, and there are some pages that I'm interested in. They're tables for so-called z-scores, and it turns out there are negative z-scores and the positive z-scores. The one I have opened here for you is called negative z-scores. And why are they negative? Well, because the z numbers they show you are on the left side from 0. On the left side from 0 means smaller than 0. So they're negative numbers on the left side. And on the right side from 0 will be positive z scores, and that's the second page of this table. So that's what I want to introduce you with. Turns out in statistics, this is something we're using all the time. So how can one use these tables? Let me first of all share this link with you so you can save it somewhere, maybe in your email, so you don't forget how to get to these tables, because we'll be dealing with these tables for this week and next week, so till the end of the class. So my goal will be to make sure that you can see that this is a nice table. So I just put the link to these tables in a Zoom chat. You can check it and you can click on it. It should open tables for you. So first observation I can make is that the area that we just found, remember we actually found one area just now, and that area was from 0 to the left side. This area was 0.5, right? I found it intuitively, but turns out we could also find this in tables the following way. So if your z-score is equal to 0, or I can write this as a 0.00. Alex, why don't you just put 0? What kind of number is 0.00? Well, it turns out that I need to know number of hundreds. 2 decimals after the decimal point gives me hundreds. So notice this tables has 0 hundreds, 1, 2, 3, all the way to 900. So we base the use of tables on the last digit, on the digit of hundreds of your z-score. And then for the rest of this z, we had 0.0. So that was actually here in the first row, and on the intersection of the row and the column, we can see the area, which is 0.5000. When you say, Alex, 0.5000 is exactly the same as 0.5. And that's exactly what we intuitively saw right away. So the use of tables is the following. You need to separate hundreds from your z-score. And then what you do is find the area from that value of z to the left. And that's the key idea. The tables actually gives you areas to the left. And this way you can get probability, which is the same as area. And those are the answers. So I'd like to practice to use these tables a little bit further. And I can verify here the following. They have a little picture right there on the left side of this page that actually gives us some very interesting thing about so-called empirical rule. In fact, analogous picture is also given, I believe, in the beginning of this section. Let me double check that. Let me go back and show you the story that they have here. Let's see. See, there's normal distribution. I believe they put that percentages here. They actually have various values of z-scores, and I think those are interesting tables, but I'm just wondering where they have this empirical, or they don't. Here what they have. So there is a special little rule here that talks about areas that appear to be within 1 or 2 or more standard deviations. And that's what I want to say a few words about right now, and related with the use of tables. So let me practice a little bit. So I'm going to be looking at the situation here, deals with 1 standard deviation from mean. What does that mean? Well, if you go back to the tables that we just considered and recall that if you have 1 standard deviation, which means your z-score is equal to 1, so it's going to be the area here in between minus and plus 1. So what if you try to find the area for the particular example within one standard deviation from mean, which is from 0, you go to the 1 on the left and 1 on the right. And I could also turn this into 1.00, right? So let me go back to the tables and try to see how we can do this. So I'm looking right now at the tables, and I can see that number 1 is right here. 1. It's actually 1.0. And since I need to know the part with hundreds, so if my z is equal to 1, then I can treat it as if it had 0 hundreds attached to it. Then these tables will tell me, Alex, here's the area from the left. So area from that value of z all the way to the left is found in the tables as 8413. Do you see that? I just highlighted it. And again, how I found it, well, I went to the intersection of row with a 1 and a column with a 0 of those hundreds. Well, it's good to realize that area is always from the left, and it actually reminds us in here. And that actually we have a little extra that we don't really need in this question that asks us to find area in between plus and minus 1. So I can actually write it the following way. Probability, that's area, that z is in between minus and a plus 1. So that's actually what I'm trying to find. And so far I found already a part of this, the area from 1 all the way to the left. So it turns out that now I have to find the other piece, or area from minus 1 to the left, because that's not what I'm interested in. So what I want to do is throw this away or subtract it from what I just found. So let me try to do this. I will go to negative z because now we have minus 1, right? So let me scroll up a little bit, and I'll see that minus 1 appears here on the negative z tables. It's on the bottom. Do you see it? It's right here, minus 1. So please notice that this table starts at minus 3 and then it keeps going down. So minus 2, minus 1. So eventually you hit that minus 1. And next to it, you will get that value because it's again under the column with zeros. And this is 1587.1587. So if I subtract these two, and I need to subtract this again because from that big area that I marked with a white color, I will be cutting out that pink little region, so-called tail. And when I subtract this little region from the one above, well, let's see what we're going to get. It'll be something like 8 and then 6. So it's about 6826. Or people can say about 68%, right? Approximately. And notice that that's what they actually are telling you in the exercise that they considered. So they say that 68% of the area is going to be here to the left and here to the right if you have your standard deviation equal to 1. So if you're just one standard deviation to the right and to the left from this particular center point, which is our mean. So if you go by one standard deviation to the left and to the right, then you will get such a result as 68% of the area. So sometimes people say this is a part of so-called empirical rule. It's very popular, turns out, in statistics. And it's again talking about being within one standard deviation from mean. So they're talking about being within one standard deviations, or in the next part, they're talking about being within two standard deviations. And for that matter, we have standard deviation equal to 2, actually equal to, looks like 6. So we have 6 here, and also a couple of 6s. Is it 6? I think it's 4, right? It's 4 in this case. Okay, so they say standard deviation is equal to 4. Yeah. And here was also 4. So it's 74 and there's 66. So let's double check if we indeed gonna get 95% of the area, just like we use the tables and we saw there's 68% for one standard deviation. So we can try two standard deviations. And I will use tables again and repeat the same exact bunch of steps. So we can, I guess, get used to this tables, the process of using those free online tables to get areas or probabilities calculated. Let me make a picture of this here. So I'm gonna try to find the area under the standard normal distribution. That is going to be in between two standard deviations, or people say within two standard deviations from mean. And that deals with z-scores equal to 2 or just 2.00, right? 2.00. So I'm going to be going back to my tables that I just found and try to find a 2 on that table. So let me scroll down a little bit. And notice that 2 is again on the margin here and the column. So it shows us the actual row next to 2 and 0, because we don't have any hundreds in it. So I put 0 hundreds. That will give us the area or the value here, and this value will be equal to 9772. So this is actually 9772.9772 is area always from the left, right? You see that's always giving you area from the left. So it never gives you area on the other side. These tables, so we just realize we found part corresponding to +2. Well, analogously, I need to go to the upper picture and locate what corresponds to -2, right? On my negative z-score tables, because what I need is area in between, just like in the previous example. Okay, so let us find -2, which is right here, right? The row was -2. And again, the column under 0, because for these numbers, we don't have any hundreds. So I'll use first column for all of them. And notice that this little area, I can mark it as a little tail. I put it in pink color, will be 0.0228, right? 0.228. And that's what I have to, again, subtract from my value. So to get a probability that we're in between 2 or within 2 standard deviation from center, from mean, I have to subtract again from 9772 from the whole thing, 0.0228. and see what we're going to get. It'll be something like a 0.9546, or that's what they actually called here is about 95% in the exercise in the textbook. You see, 95%. Interesting. So it looks like we're using tables and we get in this ideas of so-called empirical rule once again. So we calculate all kinds of values to the left from your particular value. So looks like they do this calculations and there are various interesting questions here that they considered. So let me try some exercises in this section so we can actually practice to use tables a little bit more. So let me go to the section end. So I just want to concentrate on this standard normal distribution. And to do this, I will look at the first group of exercises right now. So let me get some room here. I'm talking about exercises from 1 to 10. So let us, we'll just get used to these little tables. We just considered with 1 or 2 standard deviations. So how about exercise 4 that has 1.5 standard deviations? So Z is 1.5. So what they want is to find area. So let me show you how I can do this. So if Z is 1.5, they say 1.5 above mean means great, right? Above is great, below is smaller. So what I can do is find the area that's gonna correspond to my z-score equal to 1.5. So how can I do that? Area from 1.5 to the left. Well, I will go to the tables and I need to find 1.5. So I need positive 1.5, right? And I'm looking at the positive z-scores. And here's the 1.5 I found in this very first column. And since it's actually 1.5 and a 0 hundreds, right? You can put as many hundreds as you want. So there is no hundreds, means it's a 0 hundreds, which tells me we're again in the very first column. And the number that corresponds to it will be right here. It is 0.9332. So that's the area from 1.5 to the left. So I just select whatever's on the intersection of my row and the column. Let's get used to this. Let's do one more here. How about number 9 that says half of standard deviation. So half, I will again make a little picture. And I put half like that, 0.5, right? This is a half, 0.5. Okay, so let us find this 0.5 in the tables. And well, looks like it's the one above, right? It's right here. So what be the answer? 0.6915. Do you see that? Why is it 0.6915. Well, because that's a half, that's 0.5. That has a 0 hundredths attached to it. There's no hundredths at all. So I'm looking at the intersection of the row and the column, and I see 6915, which is right here, 6915. That's great.
But
So,
professor, does it make a difference if it states it's above the mean or below the mean? Because on exercise 9, it says below the mean.
oh, thank you. I wasn't careful. So below the mean will be a negative, right? Does it make a difference? The answer is yes, it does.
Yeah, because it's the
I
other
have to,
table.
yes, exactly. I have to read the question carefully. In fact, maybe you can find this area for a little quiz. So once again, as you wisely notice, it's going to be not a positive z-square, but a negative, right? So I need to scroll to negative tables. Exactly. So I just opened it for you. So could you please tell me what will be the area of a region from negative 0.5, not positive, but negative 0.5 to the left? So just tell me that in the Zoom chat as usual. So you need to find this particular z-square, just like I did in the previous examples. And tell me what be the area that corresponds to it according to these tables.